be presenting the thesis my partner Julian Romero and I, Jean Paul Valencia, did for our undergraduate title. This work present the title Design of a 29 nm ctle for a serdes interface. This is the outline, and we will begin with the problem presentation. Each communication system has three main components. In a perfect world, we would get a signal perfectly from the transmitter to the receptor. However, as the signal travels through the channel, it starts to lose quality. Why? This is mainly caused by the frequency losses due to the electromagnetic properties of the channel. We can see that at high frequency, we get more losses. That way, when we send a signal, we end seeing it distorted. This makes it difficult to the receptor to understand signals that are close as they begin to mix. This quality of signal that we describe is measured by the ideal diagram, and we want to meet the specifications to open that eye as we can see in the first picture. But how can we do this? That's when equalizers start to play a role. In this case, as a ctle is proposed, the ctle has the main objective to show a behavior which counters the channel. In this case, those characteristics are tied to the USB 4.0 standard specification. These are the specifications, and by designing an equalizer, we want to meet the conditions of the diagram we see here, as we want to meet the integrity of signals so we can read more signals better with other phases of the FA. Objectives. For the objectives, the main and specific aim to design the system while it achieves some certain aspects like reducing power consumption or validate on PVT and Monte Carlo simulations are things that we are looking for to complete. That's why we propose this methodology. This methodology went into different phases. We did first a characterization of the technology. After that, we made an estimation so we could start biasing the transistors. Having that, we started to use all the estimations that we did to get all the properties of the transistors to get the best equalizing possible results. We can see on screens that we got the results we described as the specifications at the beginning, and we propose also this architecture on circuit. As for the frequency domain result, we can see that we get a blind response for the ctle plus channel, and we also get to open the eye as much as we need to complete or meet the specifications. The application area of this work is technology 4.0, as it proposes a solution for one of the most popular communication interfaces on the industry, which is the USB protocol. As well, it aims to make more visible the integrated circuit design area in the country, given that it is growing up or in baby steps phase. As a conclusion, we see that we met the conditions to accomplish the properties of the USB 4.0 standard specifications. That we propose a state-of-the-art design, and we used something that wasn't described at the moment.